Good morning. We are the Covenant Christian Academy Advanced Classics Solar Car team. For our program overview, I want to highlight 3 things. Our student participation. We have 9 students on our team this year. 5 are returning and 4 of them are new. For our program structure, Solar Car is a club activity, which is primarily parent-led and sponsored. However, the school is providing some financial support this year, as well as elective credit options for students who complete a certain amount of hours. For our team organization, during the design and construction phase, all students work together to build both cars and better their skills. But during the race, we separate into 2 teams. The varsity team, which races the advanced car, and the junior varsity team, us, which races the advanced classic car. We built our car new in 2021. So for our refinements this year, we focused on the bubble cockpit, which we smoothed mating surfaces and made it easier to get on and off. Our array improvements, which made tilting more efficient. Our front suspension, we made more aerodynamic. And for our rear suspension, we increased the ride height, made the chain less messy to oil, and evaluated different gear ratios to see which one was the most efficient. For the horn, as silly as it sounds, we implemented a redundant horn to lower the chance of having to fix the horn during the race. For our telemetry, we utilized our data from 2021 to make our racing this year more efficient. On an engineering analysis front, for our airflow optimization, we utilized a 3D model of our solar car and to perform a full computational fluid dynamics analysis. From this, we learned that there is drag on the wheels, array supports, and the leading edge of the array. To combat this, we covered the exposed wheels, we eliminated the center array supports, and we rounded the edge of the leading array.
After last race, for the first time, we had about 4 solid days of telemetry data, which is provided right here. And the 4 things that we wanted to point out today is the solar array production, which is going to be the orange. The speed is going to be the blue. The yellow is the motor power, and then the green is going to be the battery voltage across the top. As you can see, the solar array production is choppy throughout the day because of the intermittent clouds. At the beginning of the race, for the speed, we started out pretty slow. We overcompensated and went too high, which brought the battery voltage down. After we charged it, we had a consistent high speed, which also brought the battery voltage down, and we had to compensate for that and bring the speed down. So as you can see, we have much room to improve because we started it out low. We overcompensated, which was way too high, and we had a consistent high and brought it down way too low. We obtained over 23,000 telemetry data points for motor power versus speed across the 4 days of the 2021 race. Plotting these on an Excel and fitting them on a polynomial regression line, it will allow us to estimate the optimal speed for each race day this year. For example, if we had a budget of 1600 watts per hour and we selected 1600 watts per hour, we brought it across to where it intersects the polynomial regression line and brought it down to the optimal speed, which is averagely about 28 miles per hour. The mechanical drawing of our car is going to be right here, and the 3 things we want to highlight today is the body and frame, which is made of aluminum monocoque, and the side crush zones, which is filled with hexyl honeycomb and is designed to distribute the impact force to the bulkhead and the bulkhead in the front and the bulkhead in the back. The suspension roll bar and upper crash zone is made up of steel for extra strength.
For our high voltage schematic, we have our 1800 watt array located at the top, our Outback Power MPPT charge controller, our 5 kilowatt hour battery pack, and our 3 kW golden motor. From a design and construction point of view, we have 3 main points that we want to get to. First is our bubble cockpit. So last year, our bubble cockpit was the last thing we created, so you can already tell that it was probably low quality since we were rushed. So this year, we refabricated it to make it have a greater airflow and less drag, and you can see here this is our finished result. Our second point is the array improvements. So again, last year we had to implement a lot of mechanics into it, and then it took a long time to just tilt it over. So this year we actually inserted those mechanics under the array. So now we just have to loosen a few screws and we can tilt it better than last year, and it takes a lot less time to do it.
This is the design and construction for the front suspension and improvements. In the bottom left, you can see the covering for the wishbones to make them more aerodynamic. In the middle and on the right, you can see this new composite wheel covering we made. In this middle, you can see these foam inserts behind where the suspension pieces enter the side impact structure, and they're to reduce airflow relative to the holes. We conducted our first testing at Dragon Stadium in Carroll ISD, and we are currently working on fixing the minor problems identified during the testing, and we hope to do another longer road test just prior to the race to identify any further problems with the car. Thank you.